nervous system of our modern world. Everything from your phone to a spaceship relies on this tiny city of gold lines, the printed circuit board. Did you know? The most common base material for a circuit board is FR4, a strong, fire-resistant fiberglass. Technology wasn't always this small. In the old days, connecting electronic components was a nightmare of point-to-point wiring that was complex and fragile. Did you know? The very first electronic devices, like radios and early computers, were all wired by hand. In 1936, an engineer named Paul Eisler had a breakthrough. He wondered, why can't we print electrical connections onto a flat board, just like ink on paper? Did you know? Paul Eisler created the first printed circuit to be used inside a radio, not a computer. Every circuit board starts with a substrate. This is usually a thin, rigid sheet of fiberglass that acts as the floor for our electronic city. Did you know? The FR in FR4 stands for flame retardant, meaning it won't catch fire easily if the electronics get hot. Next, we glue a thin layer of copper to the board. Since copper is a great conductor, it allows electricity to flow easily through the circuits. Did you know? The copper on a PCB is often only 35 micrometers thick, about half the thickness of a human hair. To create the circuit pattern, we cover the copper with a special blue liquid called photoresist. This material is very sensitive to light. Did you know? Photoresist was originally developed for use in the printing and photography industries. We shine ultraviolet light through a mask to harden parts of the blue liquid. This light literally draws the blueprint onto the board. Did you know? This process is called photolithography, the same technique used to make the microchips inside your computer. The board is dipped in a chemical bath that eats away all the copper that wasn't protected by the hardened blue pattern. This process is called etching. Did you know? The etching chemicals are usually recycled, so the copper can be used again in other products. Once the blue resist is washed away, look! The beautiful copper paths, called traces, are finally visible, connecting one side of the board to the other. Did you know? Traces act like wires, but are much more reliable because they are bonded directly to the board. To connect different layers of the board, we use incredibly fast drills to create tiny holes called vias. Some are smaller than a needlepoint. Did you know? High-end PCB drills can spin at over 200,000 rotations per minute. The holes are plated with copper, so electricity can travel through the board. It's like building elevators in a skyscraper to move between floors. Did you know? Electroplating uses electricity to move copper atoms into the holes, coating them perfectly. Now we apply the solder mask. This is the green coating that protects the copper from moisture and prevents short circuits. Did you know? While green is the most common color, circuit boards can actually be blue, red, black, or even white. We print white letters and symbols onto the board. This silkscreen layer tells engineers exactly where each part belongs. Did you know? The silkscreen uses the same basic technology used to print designs on your favorite t-shirts. Modern electronic parts are tiny. These resistors and capacitors are so small that humans can't easily hold them with their fingers. Did you know? The smallest electronic components are 0.2 millimeters by 0.1 millimeters, roughly the size of a grain of salt. A pick-and-place robot moves faster than the eye can follow, grabbing components and placing them perfectly onto the board's traces. Did you know? A single robot can place up to 100,000 components in just 1 hour. The boards travel through a reflow oven. The heat melts the solder paste, permanently gluing the parts to the copper traces. Did you know? The oven has different temperature zones to heat and cool the board slowly so the parts don't crack. Some boards aren't just one layer. Powerful devices like your phone use boards with up to 20 layers of circuits stacked on top of each other. Did you know? These multi-layer boards are pressed together with heat and pressure until they become one solid piece. We use X-ray machines to look inside the board. This ensures that the hidden connections between layers are perfect and strong. Did you know? Automated Optical Inspection, AOI, uses cameras and AI to check for mistakes faster than any human could. Engineers are now creating flex circuits that can bend and fold. This allows us to put computers into clothes and curved screens. Did you know? Some new flexible boards are made of materials that can decompose, making electronics better for the planet. From the first radios to the future of robotics, the circuit board remains the heart of innovation. Technology continues to grow because of curious minds like yours. Please like, subscribe, and share this video with students, parents, and educators to help grow the channel. Did you know? The global PCB market is worth over $70 billion, proving how important these little boards are to our world.